Okay, so welcome back. Open your notebook to page 48. You should already have this paper taped on the left-hand side, but if you do not, you can pause this and you can go ahead and you can write down these words and just leave blanks. And if you need to go on to the second page, that's okay, but pause and write this down if you don't already have all of these blanks. So here's our reading. I'll zoom in and I'll read this to you, and you guys can pause and fill in the blanks in your notebook, and you'll also answer the questions in the Edpuzzle. How is mass conserved or protected from loss? Imagine an evening campfire. Maybe some of you guys, especially if it was cold over the break, maybe some of you guys went camping, and maybe some of you guys actually got to build a campfire. I know that we have a fire pit, and I wish that we had it all prepped and ready to go over the break, because there were some super cool evenings that would have been really nice to maybe have some s'mores. Maybe you could still do that this evening. So as the wood burns, you notice that the logs have become a small pile of ashes. What happened? Was the wood destroyed by the fire? A scientific principle called the law of conservation of mass states that matter is neither created nor destroyed. So what happened to the wood? Think back. Did you observe smoke rising from the fire? When wood burns, atoms in the wood combine with oxygen atoms in the air in a chemical reaction called combustion. The products of this burning reaction are ashes as well as the carbon dioxide and water vapor in smoke. The gases escaped into the air. We also know from the law of conservation of mass that the mass of the reactants must equal the mass of all the products. So how does that work with the campfire? Mass, a measure of how much matter is present in a substance. Law of conservation of mass states that the mass of all reactants, remember that's on the left-hand side, must equal the mass of all products, remember that's on the right-hand side, and that matter is neither created nor destroyed. If you could measure the mass of the wood and oxygen before you started the fire, and then measure the mass of the smoke and ashes after it burned, what would you find? The total mass of matter after the fire would be the same as the total mass of matter before the fire. Therefore, matter was neither created nor destroyed in the campfire. It just changed form. The same atoms that made up the materials before the reaction were simply rearranged to form the materials left after the reaction. Atoms are not created or destroyed in a chemical reaction. The chemical equation for the combustion reaction below shows the materials involved in this reaction. So we have wood, we've got burnt in oxygen, and that gives us or yields a bunch of ash, carbon dioxide gas, and water vapor. So this mass of the wood and the oxygen is equal to the mass of the ashes, the carbon dioxide gas, and water. Remember that chemical equation, chemical formulas, and symbols written to represent a reaction. Chemical equations represent the conservation of mass in a chemical reaction. In a chemical equation model, chemical formulas and symbols are used to represent a chemical reaction. The reactants are on the left side of the equation, and the products are on the right side of the equation. According to the law of conservation of mass, the mass of all reactants must equal the mass of all products. Reactants, a substance that takes part in and undergoes change during a reaction, and a product as a substance produced during a chemical reaction.